Alex.
All right.
Hey, everybody. Hey, Alex, if you're hearing this.
Okay, quick reminder, when we do a logarithm, so let's say we have log base, I don't know, a equals x. If I change that to exponential form, that would be b to what power? To the x equals a. All right, so when we're solving logarithmic equations, sometimes what we have to do is we have to change it into exponential form in order to solve. Okay, so let's try this. Yeah, so little base, so 8 becomes a big base. What is the exponent? 4/3 equals x. Now, 4/3, we can reevaluate this by changing it into a cube root of 8 to the 4th power. So remember from our previous chapter, the bottom number is the root, the top number is the power. So what is cube root of 8? 2. What's 2 to the 4th?
No.
Yeah, no, you're right. 16. Okay. All right. Okay, let's work harder on it. Okay, who wants to set up the next one? Max?
Okay, so log base 16
of x equals 3/2. So we want to rewrite this in exponential form.
Okay, in exponential form, this last time.
Yes.
So you take 16.
Yep.
To be 3/2. Equals x. All right, my setting up is done. Good luck, everybody.
Okay, so where it is 16, and then we want to cube that. So 4 cubed is 64. Okay. Yeah, sure, Giddy. So what's it going to be?
X to the power of 5 x 5 over 2 equals 32.
Okay, how do I isolate x? How do I get rid of a 5/2 power?
You should you do like 5/2 power.
Okay, so I want to make this x to the 1st power. So what would I multiply 5/2 by? I would multiply it by 2/5. So that's what I'm going to do to both sides. Again, we haven't done anything quite like this. This is new, but you have all the skills from previously. Okay, so x is going to be... Okay, all right, Giddy.
Okay. It'll be 5 root
Good.
32, and then that squared. 5 root 32 is like, what is that?
2.
2. Okay. 4.
So 2 squared is? Okay. I believe. Okay. Next. 8 to the x equals 1/2. Okay, now we can't do root x. This goes back to changing both sides so they have the same base. So on the left side, I'm going to make this 2 to the 3rd.
Over 2 to the -1.
2 to the -1. So if I have 2 to the 3x equals 2 to the -1. Okay, so 3x equals -1. All right, good. Okay. Okay, if we have the same logarithm on both sides of the equation, just like here, remember when we had the same base, we were able to make the exponents equal. If we have the log of the same base, then we can make what we're taking the logarithm equal to each other. All right. One quick note, the domain for logarithms have to be positive. So sometimes when we solve, if we get a negative number and we plug it back in, you can't have a logarithm of a negative or a logarithm of 0. Okay, so we have to check
Wait, so then
answers.
A, you just do x squared equals negative 6x minus 8. What you're saying?
Right, so when we have log base 4 on both sides, basically these are going to cancel and we're just going to get x squared equals negative 6x minus 8. Now because we have a quadratic, the next step is to move everything to one side, make it equal to 0, and see if it factors. So I have x squared plus 6x plus 8. So x plus 4 and x plus 2.
X equals negative 4.
So x equals negative 4.
Equals negative, so it's not false.
Okay, so let's double check. If we plug it in on the left side, that's okay. That would make that a positive 16 and a positive 4. But what happens when I plug this in on the right side? Do we get the same thing?
No.
It's still
Let's
positive.
check.
It's still positive.
We get 18.
Oh,
No, we get 16. We get
16, you get 8, and you get.
Okay, so we're going to check.
We get 8.
Oh, it works.
Oops.
Alright, we're good.
No, we have to do 16 minus 8.
No, the 16 is already when you minus it. Negative 6 times negative 2.
Oh, yeah.
So you just gotta cancel the logs out.
Okay, so we want to see, do we get the same thing on both sides? And do we have, so on the left side, that's going to make that log base 4 of 16. Do we get the same thing on the right side? So this will be a positive 24 minus 8.
What?
Okay, so negative 4 works. What about negative 2? Does negative 2 also work?
Yes.
Let's see. Negative 2 squared will be positive 4. Negative 6 times negative 2 is 12 minus 4. Does it work? Geffin's shaking his head no. Do we agree with him?
I didn't even look at it. I'm sure.
He's just shaking his head. That means I will have to check. Yep.
So if x is equal to negative 4 and negative 2, can you use like negative 2 on one side and negative 4 on the other? If it's like, it's okay.
No.
Or
Because you only have, it's only one thing.
You have to check one thing at a time. So in this case, I do get the same thing on both sides. So even though x was negative, when I plug it back in, I get a logarithm of a positive number. And so that's okay. So actually both of these work. Okay, next one. We're going to cross off log base 5. We got x squared minus 10 equals 3x. Same thing. We're going to subtract 3x.
Minus 5 plus 2.
Good. So what two numbers multiply for negative 10? Add up to negative 3. So minus 5. So we get x equals 5 and negative 2. Let's see if we could plug in without doing all the work. So if I plug 5 back in, that'll make that 25 minus 10. So that'll be log of 15.
That works.
If I plug it in on the here, does that work?
Yeah.
Yeah. What about if I plug in negative 2? So if I plug in negative 2, that'll be 4 minus 10, which is negative 6.
I mean, like they
You get the same thing, but you can't have, you can't have a log of a negative. Well, no, just x equals 5.
What if they both go into a medical solution?
Correct. Both of them don't. So,
But you said you can't have a
so-
negative for the last one.
so logarithms, you could have both of them work. You could have one of them work, or 0. None of them work.
Why does it say this? Well, how do we do the last one? Negative 4.
Because you see it, because you have a negative 4 squared. So you multiply because the x is squared.
Oh, but this to the
For this one, we're just you're not it's not squared. You're
It's supposed to be an
multiplying. It should be 3 times negative 2.
That I
Should
might
be a
have
negative
edited.
6.
Like if we sell it,
Okay, but yours might be a little different. Okay. I might have more examples on here.
Oh yeah, I don't have any of them yet.
So you need more examples.
It's not all of them.
Okay, x squared minus 2x minus 15. What two numbers multiply? Minus 5 plus 3. Okay, that means we should get x equals positive 5 and negative 3. If we plug 5 back in, do we get them equal and both positive? Yep.
Works,
Negative 3 doesn't. Good.
So can you just see up like right from that?
Yeah. Well, because if I look here, I don't really care about that, but if I plug in negative 3, I'll see that right away it doesn't work. Okay, same thing, right? We're going to cross these out. X squared minus 4 equals 3x. So we have x squared minus 3x minus...
Wait.
What?
Last one you did wrong. I did wrong. It's not x squared minus 15 minus 2x. It's not 5 and 3.
Negative 4 and 1.
It is.
Okay, so how? 5 and 3 don't multiply to 2.
No, they add. Negative 5 plus 3 is 2.
I should go again.
Yeah. Okay,
Negative 4 and 1.
so x minus 4, x plus 1.
4, negative 1.
So we get, which one works?
Doesn't negative 3 work?
No, because on the right side it'll be negative.
4 words.
Isn't it 9 minus 15 over the same?
Where?
How
This?
is it?
But if I plug it in here, that'll be a
4 words.
logarithm of a negative 6.
4 works.
So when you
negative 1
put-
doesn't.
Like, it's not that necessarily you get the same thing on both sides. It's that you also can't get a logarithm of a negative.
4 works. 1 done.
Okay, one more like this.
We just did.
All the teachers are doing that nowadays. Oh, is that not
I'm
popular?
not a they didn't have, I got the 365.
We did that problem, no?
Did we do this one already?
I didn't do any
Sure,
of
we
them.
did this last.
So,
Yeah, this is the first problem.
is it last?
Oh yeah, you're right. Never mind.
Yes. Oh, is the next one? Oh, no, well,
Wait,
it's different.
how do you do that?
I don't like things like this.
Okay.
Wait, is there no like this noise on it? There is, right? Screen cap. Yeah.
Okay, I don't have a logarithm on the right side, so I want to.
It's just 2 to the power of 3 equals x minus 4.
Yeah, let's rewrite it in exponential form. Little base
To the
becomes
power of 3.
big base to the power of 3. Because that's what we were doing at the very beginning. Remember, we're taking, so when there's only one logarithm, we're going to rewrite it in exponential form. So that'll make this 8. And then we'll add 4 to both sides.
X equals 330.
Yep.
Yes, no, fine.
Good.
Can I petition to change my last semester grade? Is that like a possibility?
Don't think that's going to work out.
Last semester, I had a B minus.
Okay.
You got a B minus? I did with a B minus last semester? Yeah. A B plus, I mean B plus. I don't know. No, B plus. Wait. I like an 86. By 1%.
Okay. Next one, we want to solve each of these for y. So I want to try to isolate y. So first thing, we're just going to solve this in the beginning, like a normal equation. So I'm going to add 15 to both sides. So I have x plus 15 equals log base 4. Oh, sorry, I forgot my 7. 7 log base 4 of y. Now I want to get rid of the 7. So how can I get rid of the 7? We're going to divide both sides by 7. So I have x plus 15 over 7 equals log base 4 of y.
And then you turn it out.
And now I turn it into exponential.
Sounds like it would have to be 4 to the power of x plus 15 over 7. When's our next class? That is crazy. Tomorrow? Oh, tomorrow. That's the answer?
Yeah, we're just going to, because listen, we're just isolating y.
I'll do the next one.
You can't do anything with this exponent anyway. So it's just going to be 4 to the x plus 5,
terrible
15 over 7 equals y.
That's disgusting, man.
Okay, next one's,
Yeah, this is,
no, it's not harder.
okay, I'll do
First thing, what are we going to do?
divide by 2.
Divide by 2.
Okay, so then you get log y,
Base
log
y.
base y x equals 3. Okay.
Okay.
Here we go. That, I believe, would you like, well, I didn't say
Okay,
that.
okay, Giddy,
Sorry, I'll
Giddy,
do that.
Giddy offered. Y to the,
So this is y with can I go to the job? Oh yeah, y, oh no, you can just do it right now. Oh, okay, y to the 3rd.
okay. How do I get rid of a third power? Cube root. So y equals cube root of x. Next, what do we do first? Add 1. So I have 2x plus 1 equals log base 3 of y.
3 to the 2x plus 9 equals y.
Yep. That's it.
So the next one we
Are we gonna do the homework together?
We have time. So now 3 to what power? X equals. Okay, and then I need to isolate y by.
You add 2 to the 3 to the x.
You know, you literally just leave it as 3 to the x plus 2. You can't actually add anything.
No, that's it.
That's it.